So what we're doing today is we are solving more types of log problems. Some of these are going to look familiar because we have dealt with them a little bit already. The ones on the back page deal with a property of logs that I talked about a little bit, but we haven't actually done anything with it yet. We're going to just deal with it today. So if you have a single log on one side of the equal sign, we've dealt with these kinds of problems before. All you want to do is you want to take it out of log form and then you solve for your x. So our base here would be a 4. Exponent is always on the other side of the equal sign, so I get a 4 squared. And then it equals our x plus 3. Now we have a nice easy equation to solve here. So what is 4 squared? 16. And then what do we do with our 3? Subtract it. So we get x equals 13. Easy peasy. So on the second one, though, how many logs do we have on the left side? 2. So what we have to do is we have to condense it using our log rules, and then we can do the same steps we just did. So since they are adding, which means I do what with my x and my x minus 7? Multiply them. So log base 2 of x times x minus 7 equals a 3. Now we have log written once just like we did in our last problem, so we're going to take it out of log form. What's our base? 2. Our exponent? 3. And then it's going to equal your x times x minus 7. Yay, everybody loves factoring. So 2 to the third is what? 8. And then we have to distribute our x over here, so I get x squared minus 7x. And then we want to bring our 8 over so that we can actually factor, so we'll subtract it. So I then have my 0 equals x squared minus 7x minus 8. Which, how would that factor? Would our signs be the same or different? Different. 1, 8, yep, so plus 1 minus 8. So then we would set them both equal to 0, so I would get x equals 8 and x equals negative 1. Now the thing is, we still have to check. And our rule is you cannot take the log of a negative number. It's not something that you're able to do. So if I plug negative 1 in for this x up here, I would be trying to do log base 2 of negative 1, which I can't do. So we end up having to reject this one, because you cannot take the log of a negative. But if I plugged into my 8, would I get a negative number at either one of them? Here I'd be taking log 2 of 8, that's fine. 8 minus 7 would give us what? Positive 1. I can do log of positive 1. So we're going to keep the 8. So our answer would be x equals 8. Now you have to be careful. You always want to check those because sometimes it's not a negative when you plug it back into the problem up there. And we'll see an example like that. You cannot take the log of a negative number. The answer could be negative because when you plug it back into the original, that's not negative. All right, so number 3. First, we have to take care of our exponent. So I have log 3 of x squared minus log 3 of x plus, or x minus 2 equals a 2. If I'm subtracting the logs, that means I'm really doing what? Division. So that would be x squared over x minus 2 equals 2. So now we're down to just a single log, so we have to take it out of log form. So our base is a 3, exponent is a 2, and it's going to equal your x squared over x minus 2. So our 3 squared there, what does that turn into? A 9. 3 squared is 9, so I'm going to change that to a 9. Now there's 2 ways we could solve it from this step. Who thinks they know one of them? That's one of them. we could multiply both sides by x minus 2. What that does is it cancels out your denominator over there, so we're left with just an x squared. And then over here we would do 9 times x, so that's 9x. 9 times your negative 2 gives us a negative 18. And again, we're eventually going to have to do what? Factor. So we want to subtract our 9x, add our 18 over to the other side. I'm going to put my factoring up here. So we have x squared minus 9x plus 18. When we factor, will our signs be same or different? Same. They're both going to be what? Negative. What multiplies to give us 18 but would add to give us 9? 6 and 3. So we would end up getting x equals 6 and x equals 3. If we plug those into the original, would either of those give us a negative? No, Mrs. Pelkey. Oh, good job, guys. So you would end up keeping both of those answers. All right, number 4. Do we have any exponents? Yes. Any number out in front is an exponent. So we have an exponent to go on the x plus 6. So log 2 of x plus 6 squared minus log 2 of 16 equals a 2. So again, subtraction means you're actually doing what? Dividing. So it'd be x plus 6 squared over 16 equals a 2. So now we'll take it out of log form. So what's our base? 2, our exponent, 2. And then x plus 6 squared over 16. So again, 2 squared equals what? 4. So I'm going to change that into a 4. Now here we could do like what we did the last problem. I could multiply both sides times 16. But the other way we could do it is you could put this over 1 and then do cross multiplication. That would also work. So 1 times x plus 6 squared is x plus 6 squared. 4 times 16 gives us 64. And again, there's 2 ways we could keep solving it from here. Who thinks they know one of them? Since this is squared, what could we do? You could write it again and multiply. Or, I think I heard somebody starting to say it, faster way. Take the square root of it. Just like if you were completing the square, you would take the square root at this step. So x plus 6 equals what? Oh, not just 8. Plus or minus 8. And then what do we do with our 6? Subtract it. So we would have 2 of them. We would have 8 minus 6, which would give us what? 2. Or we would have negative 8 minus 6, which would give us what? Negative 14. Which if we plug negative 14 back in up here at the beginning, I'd get a negative 8, but I can't take the log of a negative 8. So that one gets rejected. So just x equals 2 is our answer for that one. So those are our problems when you have log on one side, take it out of log form, and then you can solve it. The back is when we have logs on both sides. So the rule that we use on this one, I said, is a rule that we mentioned a little bit a couple days ago, but we haven't quite used yet. If you have a log with the same base equaling a log with the same base, you can cancel out the bases, and then those two answers are equal to each other. So like example number 1, I have a log base 2 and a log base 2. Those are the same bases, so those are going to cancel each other out. And then 2x minus 1 is going to equal my x plus 3. And now all we have to do is solve for our x. So I'm going to subtract x over, and then do what with our 1? Add that over, so x equals 4. Now the second one's a little bit different. How many logs do we have on that left side of the equal sign? 2 of them. You've got log base 3, log base 3. So we have to condense that down to 1, like we did on the front. Then we can cancel out our logs. So since it's subtraction, that means I'm actually doing division. So log base 3 of 12x squared over 3x equals log base 3 of 140. So now we have 1 log on each side, so they will cancel each other out. And so what can we do to solve this? Yep, put 140 over 1, and then let's cross multiply. So I get 12x squared equals what? 3 times 140. I feel like it's 420. Are we right? So now we want to subtract that over so that we can factor 12x squared minus 420x equals a 0. I love these kinds of problems because you guys always forget what kind of factoring this is. What kind of factoring do we have here? GCF. Does 12 go into 420? Well, let's check. 420 divided by 12. Oh, it does? Okay, good. So 12x and then x minus 35. So then we get x equals 0 and x equals 35. Can we keep both of those? Why not? Does it make one of these negatives up here? No, it just makes them zeros. You can take logs of zeros. So you would keep both those, 0 and 35. You think so? All right, let's find out. So over on the left side, we have to condense that first. So I need to do what with our x plus 3 and our x minus 5? Multiply, because they're being added. So log 3 of x plus 3 times x minus 5 equals log base 3 of 20. So now we're down to a single log on both sides, so they cancel each other out. So let's multiply this out. Distribute your x, distribute your 3. You have it already? What'd you get?
X squared minus 2x minus.
Good job. Yep, equals our 20. So x squared minus 2x minus 15 equals our 20 when we multiply that out. Then what do we do with our 20? Subtract it. So we get negative 35 at the end, which is definitely factorable. Yep, 7 and 5. Which ones are negative? Nope, negative 7, positive 5, because the middle term's negative. Bigger number is going to be negative. So set these equal to 0, what do we get?
X equals 7 and X equals
7 and negative 5. So if I plug 7 into here, I would get a 10. That's good. Plug 7 into here, I'd get a 2. That's good, so I can keep my 7. If I plug in my negative 5 here, though, what do I get? Negative 2. No, can't have that. So that gets rejected.
You get pledge off if you don't write this out.